Hello students. So I hope you all have gone through the notes related to the draught. Now today we are going to learn how the chimney draught can be calculated. So before that we should know what is draught. Now the draught produced by the chimney is due to the density difference between the column of hot gases inside the chimney and cold air outside. Now the chimney draught is also known as natural draught. Now, natural draught can be simplified as it is the difference of pressure due to the cold air column and the hot gas column. So now, a diagrammatic arrangement of a chimney of height h above the grate level has been drawn for you. So later on I will tell you what is the grate level. Before that, so I hope you have the idea so what happened actually inside the combustion chamber. So here the combustion chamber has been provided for the transfer of heat to the boiler. So if we can draw the boiler at the overhead of the combustion chamber, so it will transfer the heat, okay, and it will help for burning of water, okay, and to make it convert into steam, okay. Here the combustion chamber has been provided for the transfer of heat only, okay. So as you can see, so outlet of the combustion chamber is being connected to the inlet of the chimney, okay. So for escaping the burnt gases, or you can say it is a flue gases, okay, through the chimney to the atmosphere. Now what is grate level? We need to know. So grate level is the level below which the combustion occurs and pressures are same. So obviously, so above the grate level, so pressure will varies, okay. So now according to the ideal gas equations, we need to know the ideal gas equations. So ideal gas equations, so according to the ideal gas equations, we all know. So PV is equal to mRT, as so P is pressure acting on gas, V is volume of gas, M is the mass of gas, okay, R is the characteristics gas constant, and T is the temperature, okay. Now if so these equations for any sort of circumstances, okay. So if we write P is equal to V by M equals to R into T, okay. Now we know, so M by V is the density, mass by volume. So V by M is the reciprocal of density of gas, okay. Now as if we keep the pressure and characteristics gas constant as constant, so we can write rho into T will be equals to constant, right? So this is very important. So means for 2 points, for 2 consecutive points, we can say if points 1 and point 2, so these equations will be look like rho 1 T1 equals to rho 2 T2, okay. For 3 points equals to rho 3 T3, for 4 points equals to rho 4 T4, okay. So similar to that, so we can say rho 0 T0 means if we are comparing absolute 0 to if we are comparing the absolute 0 temperature to the temperature of hot air, so equations of these 2 consecutive points will be look like this: rho 0 T0, okay. So as we all know that it's a rho 0 T0, okay. As we all know that absolute 0 temperature is equals to this. So try to be funny, okay. This is not in a space. So rho 0 equals to 1.293 kg per meter cube at absolute 0 temperature, okay. So this is the density of air. at absolute zero temperature. This is the numerical value. Okay. Now this T of hot air can be written as T of gas. So how? Now volume of air can be written as volume of the gases at the same temperature. If the air is brought to the Tg, means temperature of gas, then the volume, or sorry, the density of air is expressed like, so this density of hot air will be density of air only, and this density of temperature of hot air will be temperature of gas. The equations will be rho 0 T0 by rho of air, this is hot air, and temperature of gases. Okay. This is only if we are going to relate the hot air temperature outside the chimney and the absolute zero temperature. Okay, for that only. Okay, now so we can't write rho g instead of rho of air, as rho g is totally unknown value. Okay, and that yet to be calculated. Okay, so we could not write rho g instead of rho of air. Okay, now from here we can be able to evaluate rho of air, rho of air equals to rho 0 T0 by temperature Z. Okay, rho 0 T0 by temperature Z. Now to put this one, this is a very important equation. Put this one in the square bracket. Okay, now let m be the mass of air. So mass of air per kg of fuel. If m be the mass of air per kg of fuel, so it will be equals to, so think m suffix a divided by m suffix f. Okay, so this ratio, as we all know, this ratio is known as AF ratio, air fuel ratio. Okay, so now if we are going to find out what will be the mass of gas. Okay, so m mass of gas, mg, can be equals to total mass of hot gas, divided by per kg of fuel. Okay, now so what is hot gas? How the hot gas is formed? So hot gas is the combination of mass of air plus mass of fuel. When the mass of air and mass of fuel are being combined and burnt within the combustion chambers, it will form hot gas. Okay, and kg of fuel, this will be equals to as similar as mf. Okay, now this can be written as, so ma by mf plus 1, or if we can simplify this one, this will be m plus 1, as m is the mass of air per kg of fuel. Okay, so mass of air per kg of fuel, m plus 1. Okay, now as the chimney is filled with the hot gases, as this chimney is filled with the hot gases, now what will happen? Now then the volume of hot gas at temperature Tg, okay, temperature of gas. So at temperature Tg, the volume of hot gas can be equals to volume of hot air. Okay, as we have stated earlier, Tg. Okay, now this can be equals to, what is volume? So volume equals to, so mass of air divided by density of air at temperature Tg. Okay, now so mass of air is, this is not only mass of air, this is mass of air per kg of fuel, per kg of fuel consumption. Okay, so this will be m divided by, so density of air we have evaluated already, so rho of air is equals to rho 0 T0 divided by Tg. Okay, now this can be written as m Tg by rho 0 T0. Okay, so now, so volume of air can be find out easily following by these equations. Okay, followed by this equation. So now we need to find out the density of hot gas. Okay, now density of hot gas so rho of G, so that is for we are eagerly waiting for. Okay, the density of hot gas is equals to, again, mass of hot gas divided by the volume of hot gas. Okay, now what is mass of hot gas? Okay, so mass of hot gas, I have already evaluated this one. Mass of hot gases, this is m plus 1, so just write m plus 1, and volume of hot gas is this much. Okay, m Tg, just jump a step, rho 0 T0. Okay, now this is very important. This is what we are eagerly waiting for. Rho G equals to this much. So this is the density of hot gas. Okay, m plus 1 rho 0 T0 m into Tg, or you can put the values of rho 0 and T0. Okay, so what is temperature? What is the value of absolute temperature? Okay, so value of absolute temperature is 0 degree centigrade, means 273 Kelvin. Okay, 273 Kelvin. Okay, so 1.293 into 273, it will give us 353 into m plus 1 divided by m Tg. Okay, just mark these equations. No need to mark this one. Mark these equations as equation number 1. Okay. Okay. Now let's go outside of the chimney. Now let's go outside of the chimney. So outside of the chimney, so we may be able to find out the cold air. Okay, it is to be assumed that we may be find out the cold air. Now if this is happened, then we need to consider again. So let okay, so TA is the atmospheric temperature. So this is our phase 1, and take at point 2 or phase 2 as TO as reference temperature. So this is absolute temperature. Okay, so at temperature, atmospheric temperature, rho of A is equal to air density. Okay, so this is cold air. Okay, and at T0, so density of air will be equals to rho 0, density of air at absolute temperature, right? So now relating to TA, atmospheric temperature, with absolute temperature. So we will have again similar to rho into T equals to constant. So rho 0 T0 is equal to rho A TA, okay, or rho A, this is unknown value, is equal to rho 0 T0 by TA, okay. Okay, now so when the boiler is on, then the complete height h of chimney is filled with the hot gases. So therefore the pressure of hot gases in chimney at grade level will be equals to, so suppose this is the pressure difference, so pressure of hot gases in chimney at grade level, okay, equals to del P, or this can be equals to rho G into G, this is gravitational acceleration, into total height. So these equations followed by the law of hydrostatics. Okay, suppose so this is the water tank. Okay, this is a water tank and the pipe is connected the outlet of the water tank. Now here is a tap, here is a tap. Okay, now what will be the pressure of water at this level? So suppose this height is suppose h and rho with the density of water. Okay, now so pressure found at this point will be equals to rho into gravitational acceleration into h. So this is nothing but the hydrostatics law. Okay, now we're going to follow this law. Okay, so now the pressure difference equals to rho into G into G, rho suffix G into G into H. Okay, now rho G is very much known to us, so it will be equals to M plus M divided by M into rho 0 T0 divided by Tg into G into H. Okay, so we have put the value of rho G in these equations. Okay, there should not be any doubts. Okay, this is very much easier. Okay, now pressure due to cold air. So this was the pressure difference due to the hot air. This is due to hot air. Now pressure due to the cold air outside at the grad level. Okay, at grad level is equals to rho A. Outside means we will find atmospheric, means air density at atmospheric temperature. Okay, so rho of A into G into for the same height h. Okay, now so rho of A is known value. Okay, now this will be equals to rho 0 T0 divided by TA into G into H. Okay, so now we have already stated that what is natural draught. So natural draught is the difference of pressure due to the cold air column and the hot gas column, means it is cold air density or cold air pressure minus hot air pressure. Okay, so because the density of cold air obviously more than the density of hot air. Now so natural draught do not write it, don't write it delta P. Okay, it is only pressure, not pressure difference. So this was my mistake. Okay, not pressure difference, only pressure. Okay, a natural drought, so this will be the pressure difference. Okay, so this one minus this one, so this will be denoted by delta P. Okay, the pressure of cold air minus pressure of hot air. Okay, okay, now this will be equals to rho 0 T0 by TA to G into H minus m plus 1 by m, try to put in within bracket, Tg into H, try to put it within parenthesis. Okay, now this will be sorted as delta P equals to, now I have jumped one step, I know you can be able to understand. To 1 by Tg. So this is very important equation. Very important equations. Okay. So mark this one as equation number 2. Okay. Okay. Now, so the pressure of any fluid can be measured with the instrument known as manometer. Okay. So how the manometer is look like? I'm trying to suppose. So manometer maybe several types. So this type of manometer is generally used for measuring the pressure. So this type of manometer is known as U2 manometer. Suppose this is the terminal of a pipe. So through this pipe any fluid is flowing. Okay, pipe. Now this terminal means one terminal of manometer is connected this pipe, and another terminal, it might be opened at atmosphere, or it might be again connected to the another pipe. Okay, this manometer used to contain any heavy fluid for measuring the pressure. Okay, any heavy fluid. Suppose, so this pipe containing water. Okay, this pipe containing water, and this fluid is mercury, means mercury is heavier than water, and this point or this terminal is open at atmosphere. Then what will be the level of mercury level? So obviously the pressure due to the water will be more than this side will be increases, and this side will be comes over here. Okay, now how to measure the pressure? About this sort of, so this is totally water, this is totally water, and from here to here it is mercury. Okay, now suppose this height is h. Okay, and from this height and this height, this is suppose s. Okay, now how to measure the pressure? So actually for manometer, this is known as left limb, this is known as right limb, limb, limb. Okay, how to find out? So at the left limbs, so pressure will be equals to, obviously this is the datum level, this level is datum, like grade level. Okay, this is datum, datum, datum level means below the datum level, so pressures provided by the fluids are equal. Okay, so above the datum level pressure is, so at the left limb pressure will be equals to, so rho of water. So U2 manometer following or not following, always law of hydrostatics. Okay, now so this is filled with water, this is totally opened at atmosphere. Okay, now rho of W, then G, and this much height up to datum level, and at the right hand side, so here this much is the mercury level. Okay, above that atom level, so we can write rho of mercury, that is Hg into G into this sort of height, that is H minus S. So in this way we can be able to find out the pressure difference. Okay, now similar to this, if a U2 manometer can be added at this point, suppose at this point, okay, at this point, suppose this, okay, so from here the gas will be flowing and coming to the manometer. If first we will consider the manometer is filled with water, this much is the water. One end of the manometer is opened at atmosphere and another end is connected to the chimney. Okay, okay, so now now the pressure difference, causing the flow of gases through the chimney can be measured with the help of manometer containing water. Then the delta P pressure difference, if a manometer, okay, delta P equals to rho of W, like this format, okay, into G into height of water level. Okay, there should not be any doubts. Now here this delta P is due to the water column. Okay, water column. Now this water column is actually or normally is very less. Okay, is very less. So it is being measured in mm. So this value is measured in mm, means HW is in mm. Okay, now we need to convert this one in meter. Okay, so how? Delta P equals to, we all knows the density of water is 1000 kg per meter cube into this G, this will be unaltered, and this HW will be equals to HW by 1000. Okay, so this is being converted into meter now. Now this value will be equals to G into HW Newton per meter square. Okay, we'll mark this one as equation number 3. Okay, now equating equation number 2 and 3, we get, so what we get? We'll get, so these equations and equating with this one, we'll get, so we'll get this one. Okay, so from here we'll be able to find out the water head. Okay, is equal to 353, so this will be cancelled out, 353 into H, we take TA as common, equals to 1 minus m plus 1 by m into TA by Tg. Okay, so it is in meter. Mark this one as equation number 4. Okay, now so this gives the relation between HW, means water head, okay, column of water head, to the height of the chimney. Okay, now if the same pressure difference in terms of the gas column instead of water column, okay, is taken, then what will happen? Means if this much part is filled with the gas column, filled with gases. Okay, then what will happen? Now for that, now for gas column, so pressure difference will be equals to rho of G, okay, into G into height of gas column. Okay, now rho of G is known to us, m plus 1 by m into rho 0 T0 by Tg into G into Hg. Okay, so mark this one as equation number 5. Okay, so now again equating equation number 5 and equation number, where it is, yes, here it is, equation number 2. Now equating equation number 2 and 5. So we get, so what we get? Okay. So what do we get? M plus 1 by m into rho 0 T0 by Tg into G into Ag equals to that, the value of equation number 2. Okay, Ta by m plus 1 by m into 1 by Tg. So from here we can be able to find out the gas column head, that is Hg. This is gas column head. Okay, sorry, okay, so this is, so it is also in meter. Okay, again if we want to make it simpler, this will be equals to H into m by m plus 1 into Te, sorry, it is not T, Tg multiplying with 1. Okay, Ta minus 1, it is in meter also. Okay, so mark this one as equation number 6. Okay, now we are interested to find out the maximum discharge of gases, okay, passing through the existing height of the chimney, as it is depends upon the temperature of gases, that is Tg. So passing through the chimney, so this is because the Hg means this one, the gas head is solely dependent on Tg, as all other factors remains constant. Okay, okay, now this, put this one, this relations in the square bracket, also put this relation, where it is, yes, here it is, in the square bracket. These are the very important relations, and this may comes for numerical purpose. Okay, this may come for numerical purpose. So now we need to find out, so what amount of maximum discharge, what amount of maximum discharge has been took place through the chimney. Okay, so means condition for maximum discharge through chimney, condition Okay, so what is the conditions of conditions for maximum discharge through chimney? Now we need to know what is the discharge. Okay, so discharge means may be classified into two categories. One is discharge of volume, another one is discharge of mass. So discharge of volume means it will be expressed in meter cube per second, and discharge of mass can be expressed in kg per second. So here we will going to calculate the discharge of mass. Okay, so the mass flow rate. So discharge can be known as mass flow rate. Mass flow rate of gases, that is flue gases passing through the chimney is given by so discharge of masses can be m suffix g. Okay, discharge of gases, so this will be equals to area through which it is being discharged, okay, into velocity of gases into density of gases. Okay, so this will be equals to kg per second. So it is in meter square. This will be, so Vg velocity, it is in meter per second, and density it is in kg per meter cube. Okay, so this will be equals to kg per second, where A is the cross sectional area of the chimney and Vg is the velocity of gases. Okay, now followed by the equation v square minus u square equals to 2as. So where initial velocity is being 0, and final velocity is v. Okay, and that s can be written as height of the chimney, not the height of the chimney, the gas head of the chimney. Okay, gas head of the gas head, and after that will be equals to this mg equals to a, instead of v final velocity we can directly put the value of 2gag as, so v square equals to u square minus 2as. Okay, so this one is the v of g, so u of g, and this one a will be equals to gravitational acceleration, and this s will be equals to gas head. Okay, now this one is 0, so this will be equals to v is equals to under root of 2gag. Okay, multiplied by rho g. Okay, where at the right hand side you can write that Vg equals to 2gag. Okay, so mark this one as equation number 7. Okay, now substituting the values of Hg and rho g in the above equation we get. Okay, now what we get after substituting? Mg equals to area into under root of 2g. We are going to put the values of Hg. So we have been already calculated this one. Plus 1 into Tg by Ta minus 1. Okay, this is totally under the root multiplied by the 353 by Tg. This is the value of rho g. Okay, plus m, the m, mark this one as equation number 8. Okay, now for maximum discharge we need to differentiate this mg. Okay, we need to differentiate this mg with respect to Tg, temperature of gas. So for that, so this area, this under root of 2g, m by m, 353, m plus m, these are the constant value. So we need to consider these in terms of some constants. Okay. So suppose, so first write this one x, okay, multiplied by the Tg minus y under root of h, where y, try to follow the equation, okay, y equals to area into under root of 2g into 353 m plus 1 by m, and x equals to m by m plus 1 into 1 by Ta, okay, and capital H. So these y, x and capital H are the constants. Okay, so these are the constants. Now for maximum discharge, okay, now for m suffix g to be maximum, the required condition is, so we are differentiating, we are going to differentiate this mg with respect to Tg. So dTg equals to 0, okay, or so this is totally mathematical concept, okay. So Tg is to y h Tg, okay, this is totally one half, so this is one half, okay, then into Tg inverse is to 0. Okay, students, try to clarify one thing or rectify one thing. This will be equals to only one half, okay, not negative, this will be positive, okay. So now so these are the constants, okay. Now differentiate, so think this is our x, this is y, so dx of xy, okay. So it will have, first differentiating this one, making this one as constant, this one minus x, so 1 half into differentiating of this one, so this will be minus 1 into Tg to the power minus 1, again minus 1, this is differentiating concept, okay. Put this one within the parenthesis, okay, plus now making this one as constant and differentiating of this portion, so this will be equals to half tg into x minus 1. Then so half minus 1 means minus half. Okay, and so if again differentiating of tgx with respect to tg, it will be equals to x, okay, equals to 0. Okay, or this will be okay. So now let's make it simplified. Okay, so this will be the next step. So this is very easy to understand. Okay, again, okay, so after this step will be arises. Okay, so now we have taken tg as constant from the denominator. Okay, and LCM of these two will be this one. Okay, then so look, this one multiplied by this one, so both of these cannot be equal to 0. So either this one will be equal to 0 or this one will be equal to 0. So we are very much interested about this one, not about this one. Okay, now as this one is not equal to 0, this will be equals to 0, right? This is the mathematical tricks. Okay, as h by tz is not equal to 0, so we can write x tg equals to directly jumping one step. Okay, this one, because if this below part will multiply to 0 and this will be 0, so this part plus this part equals to will be equals to 0. Okay, so now from here we can write directly x equals to 2 by tg, right? 2 by tg, or so we have considered m by m plus 1 into 1 by ta as x. So just put the value of x equals to 2 by tg, right? Or tg by ta will be equals to 2 times of m plus 1 by m, right? So mark this one as equation number 9. This is very important. This portion is, these are the ratio of two temperature of gas with the atmospheric temperature. Okay, now what we need to do right now, okay, substituting this value in equation number 6. What the equation number 6 is? Yes, here it is. Now into substituting this value, the value of Tg by Ta in equation number 6. Now what we get after substituting the value in equation number 6, substituting the values in this value in equation number 6, so we'll have, yes, I just need to write substituting this value in equation 6, we get Hg equals to H 2 times of m plus 1 by m into m by m plus 1 minus 1, means after resolving this one we'll have H, right? Means we can say gas head level or gas head column equals to height of the chimney. So this is very important, guys. Okay, this one is very important. Okay, now we have two steps left. What are they? Now from equation number 9, we need to put the values into the equation number 4. Now from equation number 9, substituting this value into equation number 4, we get, okay, means we need to interrelate the water head column with this one. TA to 1 minus plus 1 by m into 1 half of m by m plus 1, right? Means it's 2 h suffix w equals to 353 into h by 2 times of TA. Okay, now previous one is equation number 10, this one is equation number 11. Okay, now here one steps left, that is again similarly, so putting the values from equation number 9 to equation number 8, get mg equals to, okay, a under root of 2 gh, then m by m plus 1 into 2 times of m plus 1 by m, okay, minus 1 into 353 by tg m plus 1 by m. Okay. And this mg, gas flow rate or mass flow rate of gas, equal to a into under root of 2 gh into 353 by tg to m plus 1 by m. Now when we can say this mg will be maximum, so we can say this mg will be maximum only if tg by ta will be equals to 2 times of m plus 1 by m according to equation number 9. Okay, so this is only mass flow rate of gas. Okay, mark this one as equation number 12. Now we can say when the mg will be maximum, for maximum mass flow rate of gas, okay, put the value of tg from equation number 9, put the value of tg from equation number 9, so we will have okay, so try to mention at the right hand side square bracket, then from equation number 9 we can write dg by ta equals to 2 times of m plus 1 by m. Okay, now making one step jump, 8 into A into H divided by DE, where 353 under root of 2G by 2 equals to 781.8. Okay, so this is the important analysis of the chimney. Okay, then we are going forward in the next video, which will be related to the efficiency of chimney. That is very small and petty things, and determination of the chimney diameter. This is the very small thing. So this video is very important. Okay, so try to watch this one. Okay, thank you.